Now we'll see the section of a sphere by plane. Section of the sphere by plane. Okay, a plane section of a sphere, that is the locus of the common points of the sphere and plane is a circle. So that we have to prove. That means you take the plane section of the sphere, whatever the common point which are lie on the plane and the sphere is what? The circle is the circle. That we want to prove. Okay. So now suppose this is the sphere. The center of the sphere is O. The center of the sphere is O. And what we have taken? We have to find the locus of the P now. What we have to prove? The locus of the P is nothing but the circle. That you have to prove. So P is the what? The common point on the plane and the sphere. Common point on the plane. Let P be the any point on the plane section. Okay. So draw ON. So I have what? ON perpendicular to the plane now. ON is perpendicular to the plane. Where N lies on the plane now. Where N lies on plane. That means N being the foot of the perpendicular. Okay, as ON is a perpendicular to the plane, ON is perpendicular, and this N is what? Where N is in the plane, P is also in the plane. That means whole line is in the plane. If any line perpendicular to the plane, then that line is also perpendicular to any line of the plane. Okay, so that means what? ON is a perpendicular to NP. ON is a perpendicular to NP. Okay, so this is the right angle triangle. Then by Pythagoras theorem, OP square is equal to NP ON square plus NP square. Okay, so ON square plus NP square. Okay, so that means what here? NP square is equal to OP square minus ON square. So OP square is what? Okay, so as O and N are fixed. Or your O is fixed, your N is fixed because it is foot of the perpendicular. Okay. Also, therefore ON is fixed. Therefore ON is fixed. OP is radius. OP is the radius of the sphere. Therefore OP is also fixed. Now this OP is fixed. ON square is ON is fixed. Therefore NP square is a fixed constant. Therefore NP square is equal to K. That is what? Constant. So therefore NP is constant. Now that means what? The P is what? Any point on the sphere. So this is the locus of P, which is what? Distance from this everywhere is what? Same now. This NP is constant. Therefore the locus of P is a circle whose center is N. So therefore the plane section of a sphere and plane is a circle. Equations of a circle in 3 dimensions. Equation of a circle in 3 dimensions. The two equations x square plus y square plus z square plus twice ux plus twice vy plus twice wz plus d is equal to 0 and nx plus my plus nz plus some r is equal to 0 taken together taken together gives the equations of a circle. So that is what the line is what the two planes taken together is the line in 3 dimensions. So in the 3 dimension circle is what the sphere and plane taken together will give the equation of the circle. So we are interested to find the center and radius of such circle now. If you are given the center and if you are given the sphere and a plane, that means if you are given the equation of the circle, okay, we'll take a problem on it. Okay, find the center. This is very important problem. Center and radius of the circle x square plus y square plus z square minus twice y minus 4z is equal to 11, and x plus twice y plus twice z is equal to 15. Okay, solution. Given that the equations of the circle are, so there are two equations of the circle. Two equations taken together are the circle. Okay, two equations is nothing but a circle. Okay, so x square plus y square plus z square minus twice y minus 4z minus 11. This is minus 11. Okay, minus 11 is equal to 0. I'll call this as 1. Okay, x plus twice y plus twice z is equal to 15. I'll call this as 2. What I have to do? So this, okay, so this is your circle. This is your circle. So this is the back side because this is 3-dimensional figure. This is back side. This is O is your center of the sphere. Suppose this is P here. So P is what? Radius of this. What you want? This is N. This. So you want the coordinates of N. You want the coordinates of N, and you want NP. You want the distance between N and P. That is the radius of the circle, and coordinates of N is the center of the circle. That we want. Okay. So what? At least we can find the radius of center and the radius of the sphere. Okay. Center of the sphere 1 is O. What you have to do? You have to take the coefficient of x. There is no coefficient of x, so this is 0. Coefficient of y is minus 2. Divide by 2, so minus 1, and change the sign. This is 1 now. The coefficient of z is minus 4. Divide by 2, we get a minus 2, and change the sign. So that is 2. Okay. Radius of the sphere OP is equal to root of the sum of the squares of this one, and you have to subtract the constant. Constant is what? Minus d. So this is what? Plus 11 then this is root of what? So this is 4 plus 5 16. So this is 16. So this is 4. The radius of the sphere is 4 now. Okay. Now we have this. Okay. So ON is perpendicular to the plane 2. ON is what? Perpendicular to plane. So that means ON is normal to the plane. ON is normal to the plane. So therefore DRS of ON are the coefficient of x, y, z are 1, 2, 2. So now you have the coordinates of O. Okay. So therefore equations of ON are equations, because the line is what? So DRS of ON are known to you. Okay. And one point on the line is known to ON. So one point is what? That is center. This is what? X minus 0 upon 1, y minus 1 upon 2, z z minus 2 upon 2 is equal to r c. I'll call this as a 3. I'll call this as 3. Okay. I'll call this as 3. Okay. So now this is what n lies on this line. So therefore n is of the form, therefore coordinates of n, therefore coordinates of n are of the form what? Just r twice r plus 1, twice r plus 1, twice r plus 2, twice r plus 2. Okay. So n lies on the plane, n lies on the plane 2, on the plane 2. Therefore, what is the equation of the plane? Just I have written this one. Your plane is what? Just x plus twice y plus twice z is equal to 15. Okay, so that was your plane. Okay, we'll put this n in this plane. We get a value of r, so that you are we get n, and n will be what? Center of the circle. Okay, so that we got r plus 2 into twice r plus 1 plus 2 into twice r plus 2 is equal to 15. So how many r are there? So this is 4r, 4r, 8r, 9r. So this is what? 9r is equal to how many constants? This is 2, 4. This is 2, 4. This is what? 4 plus 2 is 6. Okay, 6 minus 15 minus 6 is 9. So r is equal to 1. So r is equal to 1. You got r is equal to 1. R is equal to 1. So therefore n is 1, 3, 4. Okay. So therefore center of the circle is n 1, 3, 4. 4. Okay. Now what you want? You want np. So on is what? So on is equal to perpendicular distance of O from the plane x plus twice y plus twice z minus 15 is equal to 0. If you want to find the distance of a point from the plane, write the equation of plane in the equal to 0 form. Okay. So we have to write the coordinates of O. What are the coordinates of O? Coordinates of O, 0. You will write here coordinates of O also. Distance of O is what? 0, 1, 2. Better to write the coordinates again. Okay, so this is equal to, just we will put x is equal to 0, y is equal to 1. So this is what? 0 plus 2 into 1 plus 2 into 2 minus 15 upon the square of the sum of the squares of the coefficients of x, y, z from the plane. So this is equal to, so this is 4 plus 2 is 6, so this is minus 9. So again this is 3. So this is 3. So ON is 3. Okay. So therefore OP, NP you want. OP is the radius. Okay? OP is what? The radius. You got the radius. Okay. So OP you have. No problem for this one. Okay. NP square, OP square minus ON square. ON square. So what is your OP? You got a radius, that is 4. So this is 16 minus 9 is equal to 16 minus 9 is equal to 7. Is equal to 7. So now this ON also two ways are fine, because you have the coordinates of O, You have the coordinates of n. By distance formula also you can find it. By the distance formula also you can find this. Okay. So np is equal to then np is equal to root 7. np you have to find in this way. Okay. When you can find with the help of the distance formula or just what you can. So if they want only the radius of the radius, if you want the radius only, so of the sphere, radius of the circle, so then no need to find a n now here. Okay, if only want the radius, no need to find n. Okay, your radius will be OP will get, you can find ON, then you can find this. Okay, ON is what the distance of the perpendicular from this one. Okay, so this what 3 are by distance formula also it is 3. No problem for this one. It is also 3. By distance formula also you can find this. Okay. We'll take the next problem. Obtain the equation of the circle lying on the sphere, x square plus y square plus z square minus twice x plus 4y minus 6z plus 3 is equal to 0, and having its center at 2, 3, minus 4. Okay, so what do I want? We want to find the equation of the obtain the equations of the circle. Okay, so we have the sphere. One sphere is we have. Only we want to find the equation of the plane. And equation of the plane. The center of the circle is also given to you. Okay, solution. The center of the sphere x square plus y square plus z square minus twice x plus 4y minus 6z plus 3 is equal to 0. I call this as 1. Is O. What is that? So this is your given sphere. You want to find equation of this circle. Suppose n, and this is what P. You have the coordinates of n. Okay. So we will find the center of the sphere because we need the equation of the plane now. Okay. So for that you need the center of the sphere. We don't want the radius of the sphere. We want only the center of the sphere. Okay. So center of the sphere is what? This is minus 2. Divide by 2. It is minus 1. Change the sign. This is 1. This is plus 4. Divide by 2. So this is 2. Change the sign. This is minus 2. Minus 6. So note that the coefficient of x, y, z are 1. No problem for this. Minus 6. Divide by 2. This is minus 3. Change the sign. This is 3. Okay. So this is the center of the sphere. Okay. So this is your O. Okay. N 2, 3 minus 4 is the center of the circle, given that or let we say let be the center of the circle that is provided to you. So we are giving the name for that. So therefore we are saying that let. Otherwise it is given that is the center of the okay. Now ON DRS of ON R DRS of ON R. So 2 minus 1, 3 plus 2, minus 4 minus 3, that is 1, 5 minus 7. That is 1, 5 minus 7. Okay. So now These are the normal to the plane. Okay, so equation of the plane passing through n 2 3 minus 4 and DRS of the normal to the plane are 1 5 minus 7 each. You have this point. Okay, so 1 into x minus 2 plus 5 into y minus 3 minus 7 into z plus 4 is equal to 0. So that is what? X plus 5y minus 7z. We will keep the constant here only. So this is what? Minus 2. Okay, so minus 2. We will correct the constant correctly. So this is what? Minus 15. And then minus 28. So this is minus 30. Minus 45. Okay, so minus 45. So therefore the equations of the circle are so just write this pair: x square plus y square plus z square minus twice x plus 4y minus 6z plus 3 is equal to 0 is equal to, you will write the plane x plus 5y minus 7z minus 45, okay, equal to 0 is already there. This is the equations of the required sphere. Okay, so now we'll take the next problem. Show that the points 5 0 2 2 minus 6 0 7 minus 3 8 4 minus 9 6 are concyclic. That means you have to prove they lie on the same circle or lie on the same sphere. Okay. Okay. Solution. Let the equation of the sphere be x square plus y square plus z square plus twice ux plus twice vy plus twice wz plus d is equal to 0. We call this as 1. The 4 points are concyclic if d is equal to mod of x square plus y square plus z square x y z 1 x1 square plus y1 square plus z1 square x1 y1 z1 1 x2 square plus y2 square plus z2 square x2 y2 z2 1 x3 square plus y3 square plus z3 square x3 y3 z3 1 x4 square plus y4 square plus z4 square x4 y4 z4 1 is equal to 0. Okay, so I have to prove that this d is equal to 0. So we'll put d is equal to 0. Okay, so d is equal to now. So we'll put these 4 points here. Okay, so the 4 points here, what 25 plus 0 plus 4, so 5 0 2 1. Okay, then this is what 4 plus 36 plus 0, so 2 minus 6 0 1. Then this is what 49 plus 9 plus 64 7 minus 3 8 1. Okay, so now this is what 16 plus 81 plus 36, so this is what 4 minus 9 6 1. Okay, where to find the value of this one, where to find the value of this one? So this is what 29, this is 29. Okay, so you have to write once again this. So this is what 40, this is 40, this is 40. Then this is what this is actually 50. Okay, 50 plus I will shift 1 here, so 50 plus this is 114 and plus 8 now, so this is 122 now. 114 plus, see this is 1 is shifted here, this is 50, 50 plus 64 is 114 and this plus 8, 114 plus 8 is 122. 122. Okay, so now, so this is what 16 81 36, so this is 3 so this is what this 5, so 3 133, so this is 133 133. I have to prove this is 0 now. So that means what, you know that for determinant, if 2 rows or 2 columns are same, then the value of determinant is 0. So here what, we are not making 2 columns are same, because what, the columns are containing x, y, z. Okay, so we want to prove that the 2 rows are same. So for doing some calculations, so we'll prove this. Okay, now see what is the sum of this one. Sum of this one is what, 133 plus 29 is what, this is 2 1 6 162, and this sum is 162. Okay, so what we'll do, we'll do the R2 plus R3. Okay, so R2 plus R5, R2 plus R5, R2 plus R5, and R3 plus R4 gives D is equal to, so for that your determinant will be same now, x, y, z 1. Okay, so now what you have to do, R2 plus R5, you have to take the sum of this one, that is what, 162. Okay, so 5 plus this is 9, then this is what, this is minus 9, then this is 8, and this is 2 now. Then you have to do R3 plus R4, this is your R3 plus R4, again 162, so this is 9 minus 9 8, and this is 2. We are not changing R4 and R5, so this is what, 122 7 minus 3 8 1, and this is what, 133 4 minus 9 6 1. Okay, so I did this, what, I did these two operations, I got, so this is D is equal to 0, since R2 is identical with R3. We know that in a determinant, if 2 rows are same or 2 columns are same, the value of determinant is 0. So we have proved this. So here what, the crucial part of what, so we'll take some exercise so that you will get an idea. Okay, this is the problem for exercise. Okay, show that the point minus 8 5 2 minus 5 2 2 minus 7, 6, 6, minus 4, 3, 6 are concyclic. So I hope that you can do this one. Okay, so we'll stop here.